Thank you. Thank you.
No problem. Okay, so this is a nice topic. Outline calculations. With the name, you can understand that the calculations which happen or which you design at the outline level. That's um, how you code the calculations.
Mm-hmm.
Yeah, basically, you need to understand where are your children rolling up to. Are there any values which needs to be added? Are there any members which need to be deducted? I mean, the values of the members which need to be deducted. How do you basically get this idea? What accounts need to be added? What accounts need to be subtracted? Or what accounts are used? I mean, the values of a particular account is shared a bit between more than two columns or maybe more than two members. How do you basically design the whole accounts hierarchy? Because this is where the most of the part of calculations are done. And then the others are basically using their plus operator between the products, between the regions, between the cities, between the what else I could say, between the years. You don't really have the subtract operator or some expressions which are assigned or which are pinned to a member. Agree with me?
Yeah, I've seen the subtract in our S-base application, like, in the roll up where I wanted the parent A minus parent B minus parent C.
Okay, example.
So did I hear you say subtract is not allowed, or?
I said yes, it is allowed. I mean, most of
Okay,
the times the
I heard
subtract.
not allowed or something.
No. Subtract is allowed. Addition is allowed. What I was trying to say is you'll use these subtract or addition most of the times in the accounts dimension.
Right, right.
Otherwise, it's just addition. The values roll up to the parent. Why in accounts is basically you need to understand what accounts are being subtracted between the members or between the childs or between the parents, whatever it is. There are different accounts which need to be added, a few accounts which need to be subtracted. Uh, so how do you determine what to do? It's basically this happens when you are designing the whole application. And while you're designing the accounts dimension, you look at the the ledgers, you look at the how do I say, the P&L basically, to understand how many accounts am I going to design into this outline, how many expenses accounts am I going to design into this dimension, and what account is deducted from the gross, what account contributes to the gross profit, So that's how you design, and then when you understand that, okay, now I have to subtract this amount, then you use the minus operator next to that member.
Right.
Okay.
Yeah. I've seen that in our application too. Like the example you just made, the gross to net sales is a good example. So the gross sales accounts are plus, and the rebates discounts are all minus.
Absolutely. So that's the outline calculation. One of the ways to do that is using their operators on the members. Okay, then that's called as hierarchy structures. Okay, and then there are member formulae. The member formulae are nothing but the scripts which you write. Now, when I say a script, it doesn't have to be on the calculation scripts only. The major difference is the scripts, which the member formulae are those formulae which are pretty much straightforward, and then you will not have some statements which are like fixed statements. Okay, are you aware about the fixed statement?
Not really.
Okay, so this is a good time. Okay, so let me get you an example. Now you want to calculate so you want to multiply the actuals with 3 times and store it in the budget scenario for the accounts sales. Okay, for the year 2018. Okay, and then you are using the actuals from the last year for the same month. Just stop me if you don't get it anywhere. So you are going to calculate the budget, or basically input the budget, or assign it directly if you want to. Let's pick an example of assigning it directly. Okay, my budget for this month against, so the first the first combination is budget. Okay, then the account name is sales. Okay, and then my year is 2018. This is this year, and then you are going to get the actuals from the last year same month, 2017. Okay, and you are going to assign the budget for a particular product, which is XYZ. Okay, what else is missing? So you have the product. Okay, region, let's say this is for India or New York, whatever it is. So we covered this combination, right? Now, when you cover this combination, you got to let to know the system that you are performing this operation in this combination. Otherwise, it doesn't really understand for which combination are you applying this expression, or you're calculating the budget. So you basically fix. So you know the account name, right? So it's sales. So you fix sales so that no other account is disturbed. Okay. So you fix sales, you fix the scenario. So what scenario is this? You're doing the budget, right? So you fix the scenario as budget. So you fix on the account and then the scenario and then the year. Which year? 2018. So you fix 2018. Then you fix the product, whatever the product it is. You fix the region, whatever the region it is. And then you apply the formula saying that budget equals to actual into 3. Simple. So it calculates the actual into 3, stores it in budget. But here you'll have to use the cross dimension because it's between the years. So
Right,
you will
right.
say 2017 cross dimension actual into 3. So it calculates it, it stores in there. So why are we fixing this? Because you are fixing this because you're applying the expression in this combination. Okay. Now, this is what happens in the calculation script. You need to fix and then apply whatever the logic you want to. If you remove the fix and just use the logic,
Mhm.
you can use that as a member formulae. The last example, whatever the closing balance is for the quarter, it has to be the opening balance for the next quarter. So you simply write an expression or a member formulae on the opening balance for the next quarter to pick it from the last quarter's, last month's closing balance. So how do you do that? By writing an expression, and then the value is moved into the opening balance. That's member formula. It's not just a plus or minus. You add a formula. In the same fashion, let's say you want to calculate some percentages, like gross profit percentage. So you need to execute an expression for that particular member. How are you storing that value? So you need to understand, pick the gross profit, and then calculate the percentage. That's the gross profit percentage. So you write an expression that's called as member formulae. You can do that on the member levels. Here, the hierarchy structures are listed as addition, subtraction, multiplication, division, percentage, and then this is basically the tilde, which is you ignore this particular member from the consolidation. And then this is cap, which is you never consolidate it all. You don't consolidate. You'll have lots of examples here. Okay. Shared members. Okay, we'll talk about this in a while. Yeah, here, member formula. Let's pick an example. Okay, so they pick a very good examples saying that what are the scenario variances. This is under the scenario, okay? They basically have current year, prior year, budget, forecast. And then there is scenario variance, which talks about actuals and budgets, actuals versus budget. So the formula is, current year minus budget. So that's the variance between the actuals and the budget. In the same fashion, actuals minus forecast. So this is a formula. And this is an example of writing the member formula. Okay, does it make sense?
So you write the formula at the scenario level? Oh,
You
because
can,
that's right. Oh, yeah, that makes sense. If you're comparing actual and budget, you just need to do, yeah, it makes sense. Okay.
yeah, instead of writing the whole script, executing it, and then storing it into the member actual versus budget, it's very simple. Write it
Right.
member level. It's one of the examples. Lots of examples. Okay, no, let's not go there. This one is important. Okay, so this one, these are the shared members. Okay, what are the shared members? There is a situation, or there are multiple situations where the value in a particular member has to be shared between the other members. That's when you mark that member as a shared member. Okay, so the best example is
I'm familiar, Mohammed. We have in our outline too. Like we have in like the product dimension, we have some SKUs that that are on the primary branch, and then you create an alternate product hierarchy and share them in the alternate branch.
absolutely, that's one of the beautiful examples. To avoid the duplicacy, yes, you can do that. Now, when you're using this shared members, it has to be under the same dimension. You cannot share a member which is in a different dimension with a member from a different dimension. Okay, if I'm sharing a member, it has to be under the same dimension or at the same level. You can't even share members at different levels. Okay, so there are a few conditions when you get to share, when you cannot share the values between two different dimensions, and uh, sometimes the levels as well. Okay.
So let me ask you this. So let's say I have a in the primary tree, right? I have
Mhm,
a I have two level 0 members rolling up to a parent, right? Let's
mhm.
call it A, right? Okay. Now in the alternate hierarchy, I want to share parent A, but I don't want this to be level 2. Can I have it as level 4 or 5? Can I move it up to a much higher level if I want to? Because or it could be even a flat thing. Like let's say I just build an alternate hierarchy of just parents. So I'll say parent alternate hierarchy and then put parent A, B, C, D. So in this case, in the primary tree, the parent A was a level 1. Now in the alternate, it's a level 0 kind of. So that's possible, right?
That's very possible. Yeah, that's possible. When S base encounters a shared member during calculation, there are a few clauses actually. I'm looking for them. Yeah, yeah. Yeah, yeah. It could be at any level in the hierarchy. I'm sorry, it could be at any level. Okay, so let's look at the conditions for a shared member.
Well, it says stored members. Is that typo?
Yeah, this is it has to be a stored member. Now, yesterday you asked me if if you have to mark all the members as a stored member. Okay. For all the values which are loaded from the file, for all the values which are being associated with the members, they have to be marked as stored. Okay. Now here, when we are creating the shade members, what you have to consider is shade members and the associated stored member must be in the same dimension. Now, when I say the shade member and the associated stored member, so let's say we are sharing a value. Okay. Now it has to have some value, right? That's when you can share it. So when you mark it as a shade member, you are already storing some value in there. Okay. So when you're marking a member as a shade, it already shares the value which is already available in there. And then when you are referencing it with some other member, it doesn't store the value picking from the main stored member, but it creates a reference. You know what I mean? So whenever you're going to that member, it shares the value from the member which has the stored value. Do I make sense?
I lost you a little bit. So share. So I understand a shared member. So so maybe I'll rephrase it. You can correct me if I'm wrong. So shared member can be anything, right? It can be a level 0, level 1, 2, right? I can share anything, right?
Yes.
And so what? So stored member is in my mind. Stored member. I'm thinking a stored member as something that's like a parent member, something that's being stored as opposed to be loaded, right? Is that correct? Or stored member can also be a level 0 member?
Stored member can be level 0 number. Yes, definitely. Now you basically load the level 0 values, right?
Correct.
So yeah, stored member can be level 0. It could be level 0. Most of the times it's level 0, and then when it consolidates or rolls it up, it goes to the parent levels. The roll, yeah. Let's go through this. Probably you will get to understand or read between the lines, basically. So the shared member storage property provides a way to reuse the data in hierarchy calculations that Airspace has indexed or calculated. Instead of storing the data in multiple places, shared members create a pointer to a stored member. When Essbase encounters a shared member during calculations or retrievals, it references the data in the associated stored member. So whenever it hits the stored member and then gets the value from there.
Oh, okay. So stored member is the primary
source.
Okay.
Yeah. So using shared members enables you to use members repeatedly throughout a dimension. Instead of having the same member over and over again, you just create a member, then mark it as a shared member. It shares the value from the original source. Essbase stores the data value only once, but the value is displayed in multiple locations. Storing the data value only once saves the space and increases processing efficiency. while the shared member assumes most attributes of the stored member, it has its own consolidation operator and alias, both of which are independent of the stored member. Now, how are you marking them as shared? Shared is, so what they did basically here is, first thing, the shared members, they don't store the data. They just point to a particular shared member. So this is a shared member, current year, let's say.
Mhm.
This is duplicate, right? There is a current year in scenario, and then there is a current year in actual versus budget.
Mhm.
Now they are reusing it. So they're creating current year, and then you're marking them as shared, and then you map it with the current year, which is already in the hierarchy, in the same dimension. Okay.
Yep. Now it's clear. Yep.
Yeah, and then there is budget, which you're reusing again. So you will map it with budget. Instead of storing it multiple times, you just create a member as a shade member, and then you map it with the source. Shade members must be level 0, even if the stored member is not. I think this clears your question. Yeah?
Yep.
Okay. You can have unlimited number. There is no limit. Unlimited number of shade members with the same name. Okay, now this is interesting. On the shade members, you cannot assign the UDAs, or you cannot write the formulae. This is very important.
Right.
When you mark a member as a shade member, you cannot have member formulae on it, because the answer is very simple. There is no stored value in there. It's a reference. It's a pointer. So
Right.
you can't implement formulae on the pointer. You can't use that particular member to add some UDAs to it. But you can do that on the main source. You know, the main stored member. You can add formulae. You can mark UDAs for it. And the same UDAs will apply for this shared member as well.
Mhm.
Yeah?
Yep.
Okay. And then you cannot associate the attributes with the shared members. When there is no UDA, there is no attribute as well. Now, what is attribute? So do you get that term attribute? Do you get the term attributes, Ramki?
Yeah. Yeah. I mean, I've attribute dimension, right? So it's are you referring to like an attribute dimension or?
So what happens is, yes, attribute dimension, definitely. Uh, for the refinement of the reports, or uh, for the refinement of data load. Basically, let's say you have a can, Pepsi 100 ml in can and bottle. Okay, so my can and bottle are the granular details. Okay, now when I'm talking about granular details, so if you want to have a report looking at how many bottles were sold, yeah, how many cans were sold. So this is basically looking at the details, the granular details. You can achieve this by adding UDAs to that member. So let's say Pepsi, 100 ml. On the 100 ml, you can add 2 UDAs, one can, one bottle. Okay, and then when
So
you're
you
yeah, go ahead.
add, how will the product member name look like in your example? Will it say Pepsi or will it say Pepsi 100 ml?
No, under Pepsi, Pepsi is the parent.
Mm-hmm.
Under Pepsi, you will have 100 ml, 200 ml, 300 ml, whatever.
Okay.
Yeah, and then let's say I have 100 ml bottle and can.
Okay.
Okay, now I cannot have can and then 100 ml and then bottle 100 ml. That means you're duplicating 100 ml.
Right.
So what you do is basically the common value which is repeated is 100 ml. So you create 100 ml member and then add UDAs,
Okay.
can or bottle. And when you're loading the data, it's pretty much understood, or it's written there in the report or the file if it is a can or bottle. And when the data is loaded, it is loaded with that particular UDA.
Okay. So you can have multiple UDAs on the single product, right?
Multiple, yeah, multiple. The 100 ml can be can, bottle, or what, or what, anything.
Right.
Okay,
Tetra.
so that's UDA. Now UDAs, they are, I mean, you can have multiple UDAs. Um, you can assign the same UDA between different dimensions. Yeah, you can use it in different dimensions. But that's not the case with attributes. They completely work like UDAs. It's like, again, the attribute dimension will have bottle, cans, and everything in there, and then you associate that member, the attribute member, which is a bottle with 100 ml, which is in product. The product dimension has 100 ml, right?
Mm-hmm.
And then you'll create another dimension as attribute dimension. You'll have bottles, cans, or whatever the attributes you want to associate with the product.
Okay.
Okay, and then when you map it, the member in an attribute dimension, the members in the attribute dimension can only be mapped. Let's say at the first member you are mapping it with product. You cannot have the second member mapping it with some other dimension. If you create a dimension, it has to point to the same dimension throughout. I mean, if you're creating one attribute dimension, all the members should point to the same member, to the members in the same dimension of the target. Okay, you cannot have hundreds of attributes under the attribute dimension and then map it between the members of different dimensions. That's not possible. That's one of the limitations. But in the case of UDAs, you can use the same UDA for any dimension, for any members in any dimension. That's the beauty of UDA. So that's what it's saying. You cannot associate attributes with shared members. So when there is a shared member uh, in a dimension, you cannot have some attribute assigned to it, because you only assign the attributes to the shared member, sorry, the stored members. So something which has value in there. Okay. This is something which we will deal tomorrow. Okay, designing accounts dimension. It's a very good topic. Yeah, this is nice. The consolidation order. Do you remember this BODMAS rule?
Yeah.
Yeah, that's pretty much what is applied here. Brackets, and then the order is okay. Plus, plus, minus, multiplication, percentage, division, and ignore. Okay, how is the consolidation order done? So here it is. It performs the addition first, m1 plus m2, and then it deducts it from whatever the solution is in minus m3, m1, m2 minus m3, and then it here the whole expression, this one ends here, the first bracket ends here, m1 plus m2, and the second bracket ends in m3. From whatever the result is from m1 plus m2 minus m3, it multiplies it with m4. Okay, now whatever the result is until m4, it uses the percentage symbol with m5, whatever the value is. After the whole result, it divides with m6. That's how you need to be very careful when you are using this consolidation operators. And yeah, if you miss the logic, the roll up will will result different values when it is rolled up. Yeah. So they took an example 10, 20, 25, 10 plus 20, 30. Yeah. Do you follow it?
I can follow that. Yeah.
Yeah. Beautiful. Okay. This is good. There is something here. Note. Using the top-down calculation order, as base ignores the first child of a parent if it does not have either the plus operator or the minus operator. Okay, if the first child does not have plus or minus, okay, that's what it's saying. It ignores the value, and then it goes to the next member.
Okay, makes sense. So the member one had a tilde, you're saying it'll just skip over to member two.
Yeah.
Okay.
Yep. Okay. This is something which we will talk about later. This is basically the functional aspects, performance, visibility, what you need to consider when you are designing the whatever the considerations are. So are you following this boot camp book? I mean are you getting enough time? Do you have sometime during the day where you go back and look at this boot camp?
No, I haven't had a chance yet, but I'll have some free time either tomorrow or next week, and I'll look at look at some of the topics here.
This is a beautiful topic. I mean, it tells you how Essbase uses its logic, which is intelligent calculation and default calculation script. We can discuss this tomorrow as well. Yeah, this is nice. I mean, the tomorrow's topic can have this default calculation and the intelligent calculation.
Okay.
Yeah. Okay, so do you want to spend more minutes, or is that okay?
Yeah, I think we're at a logical point, I guess, right? We don't want to start something and
New, yeah. I was looking for another short topic where we can get to, but no, there is nothing. This was a short one, so we discussed it. I may also need to go through this boot camp. I'm not getting time to basically design the topics.
right.
Yeah, I will sit on it maybe this weekend, and the next week could be a little more smoother, where I know what to discuss basically.
Sure.
I don't want to jump into creating an application, creating a database, um, creating the members, and then you don't know if you're going to mark them as a shared member or a stored member, or
Right.
you know what I mean. So, or you don't understand the logic, or we don't understand the logic if we are supposed to use the plus operator first, or the minus operator first, or the multiplication operator first, to quantify the value basically. So these are the things which are very important when you design the outline.
Sure.
So we will discuss this, and then you get to understand these are the aspects which need to be looked at while you are designing an outline. And then we'll have there is a scenario. There is a beautiful case. What do you call that? Yeah, case. There is a case which will help us design a database or an
Okay.
application.
That's
Yeah,
nice. Yeah.
that, yeah.
Excellent.
Case study. Yeah, there is a case study. Very nice case study. We can do that. All right, so Ramki, I'll let you go now. You should be very tired. Thank you for your time.
Sure, no problem. Thank you, actually, Mohammed. So we're
Yeah.
meeting tomorrow night, right? Same time, 10 o'clock, right?
Yeah, it'll be Friday night for you, right?
Yeah, Friday night. And then just to plan for the weekend, right? So I guess we won't have class on Saturday, right? Because I don't want to, and it'll be
Yeah,
Sunday morning for you. So
absolutely.
is that right?
Yeah, cool.
And then Sunday night, my time, meaning Monday morning, are you okay, or do you need the Saturday and
They
Sunday?
actually leave Saturdays and Sundays.
Oh, so
Yeah,
you prefer to pick it up Monday night, meaning Tuesday morning.
yeah,
So tomorrow will be the last class for this week. Okay. I just wanted to
yeah.
plan for
Now,
that so that we.
the reason why I'm skipping these 2 days is, I mean, for any other person, I would still use 6 days. But
Right.
for you, 5 days are good.
Okay.
And
I don't know,
yeah.
good or bad, but
No, I mean, it's cool. 5 days are cool for you.
good. Okay. No worries.
If we feel like, yes, we need more hours, then we will jump to.
Sure. No, that's fine. This is a nice balance.
Sure.
Then so so tomorrow I'll be working from home. Actually, I have a little bit of flexibility tomorrow, even during the day, in case you want to, if you want to meet earlier or something. Also, we can get it out of the way. So just shoot me an email.
Yeah, I will.
So meaning right now it's Friday morning for you, right? So meaning in another 12 hours or so, I could get online and we could wrap it up if you prefer, or else we'll just stick to the same time.
Yeah, sure. No problem. I'll let you know. Today it's going to be a very busy day for me. So
If I don't hear from you, we'll meet at 10 tomorrow.
yeah.
All right.
That
Thank
would
you. Good night. Good morning. Good night for me.
Good night to you, actually. All right. Have a good one.
Bye.
Bye.